Hi there! Today we're going to talk about superpositions. It's crazy, right? Alright, so what is a superposition? A superposition, in short, is when a particle is as a wave or a fuzz of probability. And we can take a look at Schrödinger's equation here. We use psi to measure subatomic particles because they are a wave until you observe them. And when they are observed, they snap into place, and you have a position for them. A real position, but a superposition is where they're everywhere all the time, and we have no idea where exactly they'll be. We can just guess by applying Schrödinger's equation. But we can have the sum of two arbitrary prefactors and still have two results. So that means in your SPF, summer's coming, in your SPF orbitals, your electron could be anywhere within this yellow, anywhere, at any time. Of course, we can guess with a reasonable certainty of where it will be, but we have no idea, to be honest with you. So this brings us to the Heisenberg Uncertainty Principle as well, which indicates that you cannot measure two factors of a particle's existence, such as color and shape, for example. You can only measure one at a time. And this one might blow your mind a little bit. Imagine we take a subatomic particle and we fire it into a sorter. This sorter is going to check for the color, and we're going to end up with 50% purple and 50% green. But then we take only the purple ones and we fire them out to another sorter which will check the shape. Now, we can take only the triangles and measure them again, and we will find that we get 100% purple. But if we take those and we fire them squares and triangles that we got from our shape sorter, and we fire those up and we just cut off one, we can end up with 100%. But if we fire both and they forget what color they were, forget for lack of a better term, and they end up going back to a 50-50 for color, which is absolutely incredible if you think about it. It means that on the subatomic level in the quantum world, you can only measure one thing about something at a time, otherwise it forgets what it was before that. It's trippy. This was first done by Stern-Gerlach in their experiment using silver, if I'm not mistaken. I think it was in the 1930s, but don't count your chickens before they've hatched. A lot of what happens in quantum physics has to do with the spin of the particles. We won't go too crazy into this, but spin is a very interesting thing, and I'd like to break it down just a little bit for at least the first three types of spin. The first one being the zero spin. So this one, if you were to rotate space around a zero spin object, the zero spin object will not move in relation to space that's being moved. Even though it's a participant of the space that it is in, it does not react to its orientation. In 0.5, or like a spinner, it only spins at about half the rate of the drag of the space around it. So you would have to spin the space around a 0.5 spin or a half spin twice to make one full rotation. And meanwhile, a one spin is a vector. It rotates with the space around it, as if a direction. So if you have any questions, please leave a comment below. And don't forget to like, share, and subscribe, and ring that bell for notifications for future videos. I look forward to seeing you next time. See ya!